Today we're going to be looking at systems of equations in two variables. The term system of equations means a set of two or more equations. In 2.2, we'll be getting into a set of three equations, but today we're just going to be focusing on two equations. A solution of to a system of equations is the x, y value that holds true in both statements. Another way of thinking about it is where the lines intersect, the coordinate where the lines intersect. Now, there's many different types of solutions here. Sometimes systems only have one solution. That means your lines cross once. If you were to graph this, you'd have your two lines. There's one point where they intersect. It might have infinite solutions as well. If you were to graph two lines in this case, here would be your one line, and your second line, it would be the exact same. Another way of writing this is your lines coincide. The third type of solution there may be no solutions. And in this case, your two lines would never intersect, which would mean that your lines are parallel. Today we're going to be talking about three different ways in which you can solve these solutions. The first type being solving by graphing. The first thing you want to do when graphing these is put these equations in slope-intercept. Then you graph those lines using the slope and y-intercept and find the intersection point. So the first one we're going to take a look at is solving by graphing. We have the equation y equals 4x minus 18 and y equals 3/4 x minus 5. I'm going to rewrite these on this page here. So we had y equals 4x minus 18 and y equals 3/4 x minus 5. Now when looking at our graph here, we know our y-intercept is 18 and our slope is 4. Well, negative 18 isn't going to fit on this graph. It only goes down to negative 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So obviously we're not going to graph that. So let's try something else. Let's pick a different value. Let's say when x is 2. When x is 2, if we plug that in, 4 times 2 is 8, minus 18 is negative 10. This point definitely fits on our graph. So we can plot that point to negative 10, and from this point we can use our slope of 4. Rise 4, go over 1, go over 1, and I tend to place these all across the graph, and then we can connect these, and here's our first line. The second line turns out to be a little bit easier since our y-intercept is on there. 1, 2, 3, 4, 5. Our y-intercept of negative 5 and our slope of 3/4. So from our y-intercept, rise 3. 1, 2, 3, 4. 1, 2, 3, 1, 2, 3, 4. We can see we already have where that line crosses. Now, remember our solution is that coordinate where it crosses. So our solution would be 1, 2, 3, 4. 4, negative 2 is our solution to this system. I always like to double check as well. I take that solution and I plug it back into our original equations. Does our y value of negative 2 equal 4 times our x value of 4 minus 18? Well, yes, that one works. And we can double check our second one. Does negative 2 equal 3/4 times 4 minus 5? and it works in that one as well. We're also going to look at today how to solve by substitution. Solve one equation for one variable. It can either be x equals or y equals. Substitute it from one into the other equation and solve, and then you'll substitute your value from 2 into step 1. Now this is quite a bit of words here, so we're going to take a look at our example. The first one we have here, y equals 2x plus 4. And then we also have 3x plus 4y equals 10. So substitution, our first thing it said in substitution was solve one equation for one variable. Well, we have a y equals a statement. So we're going to take what we know our y equals and plug it in for our y in our second equation. And now we will rewrite this. So this equation can be written as 3x plus 4 times what we know y is, 2x plus 4 equals 10. And now we just need to distribute and solve. So 3x plus 8x plus 16 equals 10. 11x plus 16 equals 10. Minus 16 minus 16. 11x equals negative 6. Divide by 11, divide by 11. X equals negative 6 over 11. And we have our x coordinate. Now we need to always find our y value as well. So we can go back up to this top one and we can substitute in our x value. So we know y equals 2 times negative 6 over 11 plus 4, which means y equals negative 12 over 11 plus 4. And we can come up with a common denominator here, which would be y equals negative 12 over 11 plus, let's see, what would this be here, 44 over 11. That's the same as 4. And if we add those, we have our common denominator. So negative 12 plus 44 gives us y equals 32 over 11. So where these lines would intersect, it's not nice integer values. We have some fractions, negative 6 over 11 and 32 over 11. Now this is one I would definitely double check. So let's take that first one and plug in those x and y values. Does 32 over 11 equal 2 times negative 6 over 11 plus 4? And this one, we can type it into our calculator and see that that holds true. And double check the second one. Does 3 times negative 6 over 11 plus 4 times 32 over 11, does that equal 10? Take a minute there, double check that by typing it into your calculator, and let's see if it works. And it does. So we found the correct solution to this system. The last type we're going to go by, this is the one that most people are most familiar with, is elimination. You're going to pick a variable, either x or y. Using multiplication, you'll get those variables to have opposite coefficients. Add the equations together to eliminate your variable, solve, and then substitute whatever you get for one variable into one of the original equations to find your other variable. So this one, solve systems by elimination. We need to decide first whether we want our x's to eliminate our x's or y's. And it doesn't matter, you could do x's or y's. In this case, let's say we choose our x's. 5 and 3. You want to think of what is that first multiple that both 5 and 3 go into? Well, that's 15. So 5 times 3 gives you 15. So we're going to multiply everything by 3. So we have 15x plus 6y equals, well, 340 times 3, 1020. And if this is a positive 15, that means we want our bottom one to be negative 15. So 3 times negative 5 gives us negative 15. Multiply that through, negative 15x plus 20y equals 360 times negative 5, negative 1800. And now when we add these together, 6 plus 20y is 26y equals negative 780. Divide by 26, and we end up with y is negative 30. Now again, our final answer has to have an x and y value, so we can plug it into any of these equations. Maybe we choose to plug it into the bottom one. 3x minus 4 times negative 30 equals 360, and we solve for x. 3x plus 120 equals 360 minus 120. 3x equals 240. Divide by 3, and x equals 80. So our solution is the coordinate 80 and negative 30. Now once again, I would double check these on your calculator by placing them in there and making sure that they work. Now, we have 3 equations here. You're going to solve one by graphing, one using substitution, and one using elimination. You can solve all these equations using whatever method you would like, but some of these are set up to use one method is a lot easier than the others. Such as looking across here, I would say this one, I would use elimination. They're already stacked, we just need to make opposite. Now deciding which one to graph, looking at these, well this one's in a y equals format. This one we could turn into y equals fairly easily by subtracting the x and rewriting it into y equals negative 2 minus x. And those would make it easy to graph, so I would graph these two. And looking at this one, we have an x equals statement, so we could take what we know x equals and substitute it in for our x to find the answer that way. I'm going to leave these up to you to do, but once you do this first one, you should get the answer 3, 5. The second one, 2, negative 4. And the third one, 1/3 and positive 2/3.